Hi, everybody. My name's Matthew Adams. I'm a principal solution architect with Elastic, and I'm joined today by Ed. Ed, do you want to introduce yourself?
Morning, everyone. My name's Ed Puddicombe. I'm the strategy director for Niaxo. We're here supporting Elastic this morning.
Thanks. So the session today is really a bit of a background about Elastic as a company, our technology, how we think that we fit into use cases like smart cities. And then I want to hand you over to Ed, who can really talk about, from a partner perspective, what they can build on top of Elastic to really build something bespoke. So first, a little bit about Elastic. We were formed in 2012. We're spread across 40 countries. We were sort of distributed by default. We already did our entire company worked over Zoom. So we were sort of well prepared for working at home. We're listed on the stock exchange. Again, relatively new company, about 2,500 employees now. As a principal solution architect, I focus on talking to anybody that's using Elastic technology. I focus specifically on UK government, and within that time, I've spoken to pretty much every major government department I can think of, because the technology is very broadly used. So what is Elastic? Elastic is a search company, and it's probably the most important search company that you've never heard of. We are very well known in the technical community and IT community, and not so well known outside of that. That's often because we are backing very important services. So you probably interact with a system with Elastic in it on a daily basis, and we are increasingly being used in new applications as they're built. But because we're behind the scenes, you don't necessarily understand that it's actually Elastic technology that's backing that system. So if you've ever used an app like Uber, actually behind the scenes, Elastic is powering that, right? We are providing search for cars. We are providing geo queries. When Uber is drawing the map, showing you where all those cars are, that is actually doing a geo query to say, show me the latest car locations that are in this box, which is going to be displayed on my user interface. And that's a search. You might not think of that as a search. It's not your classic type some words into a box, but that's fundamentally a search of real-time data. Obviously, there's the classic use case, things like searching for restaurants, where you've got a search box where you need to be able to bring relevant results back extremely quickly. That is all backed by Elastic, with people like Yelp embedding Elastic behind the scenes to actually provide that search experience. If you've ever used gov.uk, the search bar on gov.uk is also powered by Elasticsearch behind the scenes. Again, you need to find relevant results across what could be quite a large data set extremely quickly. And even banks like Barclays, we talked around search use cases. Actually, a huge number of our customers use us for IT observability or cybersecurity. So Barclays have built a cybersecurity platform for use internally that's all built on top of Elastic. Now, again, this may seem a little bit confusing because we've talked around search, and cybersecurity isn't traditionally thought about as a search problem. But when you think about large flowing data sets where you need to be able to ask questions of that data and get rapid responses, then actually these things map back to search and analytics. So we are used across industry. Here's some major clients that use Elasticsearch behind the scenes. And as I said, across pretty much every government department that you can think of. Uber, Tinder's an interesting use case. Again, it's matching people. There's no search box, but it's matching people on sort of structured, unstructured characteristics, and also with a geo dimension. But that's all happening behind the scenes. So actually, search is increasingly being embedded as a native part of navigating in applications, not just the sort of classic text search box. So it's extremely widely adopted technology. And that's fundamentally because we focused very heavily on the best search experience, the best search platform. And it turns out that a lot of different use cases, when you think about them, they're all actually mapping back to search. So that example of Tinder matching people together is a search, right? You're searching for all of the other profiles you have to find likely candidates for that person. If you're looking at us from a geo dimension, you need to find the closest Uber cab to you. That is fundamentally search. If you're seeing metrics coming in from the number of users logged in, where are they unique? Where are they coming from? Are we seeing an unusual number of people coming from an unusual country that could signify some kind of attack on my network? That's fundamentally a search problem. You're giving a set of criteria that you want to find, and then you want to either visualize that or alert on that data. But actually analyzing the data is a search problem. So that's why we get broadly pulled into a huge diversity of use cases. So fundamentally, the technology we provide is all based around Elasticsearch, which is the actual search engine. And then we provide various integrations for getting data into that platform, especially around the IT observability and cybersecurity. We provide agents that can help you gather that information and get it into Elasticsearch extremely quickly. We then have a user interface called Kibana that's specifically focused on analytics and cybersecurity, and as a BI tool increasingly. But you can also plug and play these components. So you can also contact Elasticsearch directly. You can use client libraries. You can build upon Elasticsearch very easily because it's an open source and very open technology. So it uses standard APIs. It uses JSON. So it's very, very easy to integrate into other tools where you saw, for example, like the Uber and Tinder use cases. They are building directly on top of Elasticsearch rather than using our user interface. And again, it's this one single stack that is covering this very diverse set of users, from a text search box all the way to cybersecurity. So I wanted to try and summarize why we see that sort of virally adopted across government agencies. So the first one is that we're very open. It was an open source background that we built Elasticsearch on, and there's a whole company Elastic around that, obviously, so you get the support that you need as well. But it means you can download it, you can start using it for free, you can start building something quite valuable to the organization without that upfront friction of going through procurement before you even know whether the thing you want to build is valuable. So it means that a development team can go and prototype something without talking to Elastic, without talking to anybody, and then demonstrate that back and be able to explain and prove the value right up front in a very easy way with very little friction. So that's hugely beneficial to adoption. Also, there's a large community of users. I think we've been downloaded more than 1 billion times. So for those teams that want to find out more, want to know how to do something, there's a large community out there where they can get support. We're also extremely flexible. A lot of government problems are quite bespoke or interesting. So like we're in NoSQL, we don't have a rigid schema. You can index structured text, unstructured text, geo polygons, geolocations, IP addresses, numerical fields, pretty much any type of data. You can index it into Elasticsearch, and we will have a dedicated way to index that data and make it extremely performant to ask questions. Also, the licensing model, so when you're going out into production, you need support and you need some of the more enterprise features. It's extremely flexible. So you're licensing on a resource-based model. So you license a cluster, for example, and then what you do with inside that cluster is completely up to you. So that ability to chop and change without being forced into a particular sort of use case box is quite important. And then like we're very scalable. So data volumes are always increasing, and we have people. You can start with Elasticsearch on your laptop. I've run it many times on a laptop, but you can then scale it up to petabytes of data. So I think eBay publicly quoted they were putting multiple petabytes of data in Elasticsearch per day. So hugely scalable and easy because it's a clustered system. It was built for cloud and built for scale. So you just add nodes, but you can also run this in cloud, or in air-gapped environments, which is obviously important depending on the data set that you want to ingest. So I think that the topic of this talk is really trying to focus on how Elasticsearch and Elastic is applicable to these kinds of use cases. And I think the theme I wanted to pull out is how the underpinning of search really can help drive innovation. So, I mean, I'm sure everybody that's worked in government for any significant amount of time will know that there's a significant problem with data. And that is fundamentally that data is extremely siloed. Right? There's different government departments will build systems. They won't talk to each other. They won't use the same technology. It's very difficult to share information. It's very difficult to bridge those silos. But even within one department, they may have multiple systems that don't interact with each other. And commonly, we're speaking to customers where they have one system, but they also have the last version of that system and the version of that system before that. So they have this sort of stacking of legacy systems that they've never managed to fully migrate off. And that's a huge pain point because you either have users going to multiple systems looking for the data they need, which is extremely ineffective or inefficient, or people just don't find the information they need, which is a huge issue. So how could we start to tackle this? If you look at smart cities, so I Googled smart cities, and what I got was a lot of images like this, right? So they focus on smart homes, smart street lights, smart everything. But if you think about like what it's showing in this picture, it's fundamentally about adding new whizzy gadgets that generate data, right? But we're not necessarily tackling the sort of possibly really important problems where we already have the data, let alone coming up with an integrated strategy for where we're going to put all this data we generate so that we can actually gain insight from it. So I think there's a huge amount of value that could already be delivered by being able to surface the information that we already hold. I'm sure everybody sort of a user of government services, by the fact that you live in the UK, I'm sure there's a lot of information about your local environment that you would love to be able to quickly ask in a government portal and get that information back, either about you personally or what the local council is doing. Typically, that information is very hard to get hold of these days, let alone like whether your street light is on or off. Right? So if we create all of these new systems that are shipping data, we just risk creating more data silos rather than actually tackling the core problem. What I wanted to draw a comparison between the banking industry. So innovation in banking was pretty stagnant, I'd say, more than sort of 5 years ago. It was very difficult. There was huge barriers to entry for small organizations to create a new service that was valuable. And that was partly because the data was locked in silos within the big banks, right? So it was in a data center, probably in an old mainframe system that was very heavily controlled, no access to third parties. But there's been quite a revolution in banking, partially driven by policy that was forcing banks to open APIs to third parties. So they had to essentially provide search of their own data. So they had to build a search platform. So they left their mainframe as is, and they built a search platform over the top of it to handle this kind of third-party queries that the existing system was never built for. And in many cases, they used Elasticsearch to do that. And then they had to open APIs to third parties. What that really did was really lower the barrier to entry to small companies that wanted to offer these services, because all of a sudden they could build a user interface, they could build up their idea, things like Money Dashboard and various other small startups that have started in fintech, because they could just hook into this API and get the data they needed to be able to power that service very, very easily without all the friction that existed before. And this feels like a very similar situation that government's really in now, and probably lessons that can be taken away. So what could it look like, right? So obviously a very high level architecture, but you can take a series of data silos and you can leave the data as is, and you can put Elasticsearch over the top as this kind of data and search layer. on top of that layer, you can build public or private APIs, and those can then power new services. Right? So somebody building a new web application for police officers, for example, wouldn't need to know that there was 7 different legacy systems where the crime records were spread across in the back end. Right? So that means that team only has to focus on integrating with a modern open API where it's very quick and easy to integrate with it. So it means that you can drive innovation very, very quickly, as opposed to the situation today where they may need to go and interface with a load of systems they don't understand. And obviously, as you build this stack, it's important to think about security. So we would be looking to sort of embed security at multiple layers, but including the Elasticsearch layer, to be able to provide the security controls that government needs around document level security, for example, to mirror the access that's really warranted to that data. So coming back to how do we drive innovation, we talked about how we can essentially put search in place as an enabler of innovation, right? So allow easy access to the data that's held in silos today. And what that really does is open up the stage for small and innovative partners that really understand data to be able to build services on top of Elastic. So that's why we invited Niaxo to speak today, to sort of flesh out the kind of services that they've been building for government clients on top of Elasticsearch. Over to you, Ed.
Brilliant. Thanks very much, Matt. I'll just share my screen. Right. Here we go. Is that sharing?
I can see it.
Fantastic. Thanks, Matt. So I'm Ed from Elastic. We've been working with from Niaxo. We've been working with Elastic for quite some time now. Bit about us, not quite as big as Elastic. We're not listed on the stock exchange, but we've been doing some really novel stuff with the Elastic Stack recently, and that's what I'll talk to you about today. So the core areas, so looking through from the left to the right: ingest, governance of the data system, the technical assurance of the feeds, the storing and index, which really comes into Elastic's core strengths, and then the insight generation, which is using the Kibana component there. So I'll talk quickly through those. So firstly, on the left-hand side, accessing data, again, as Matt has talked about, whether it be files, APIs, web scraping. We've even got a plugin directly into Excel to allow data to be shared from native platforms. The big thing that we then overlay is the data governance piece. Again, as Matt has illustrated, particularly in the public arena, knowing what we know, knowing where it came from and when it came from there, and when we had access to it. We can then put that through a series of technical checks, sometimes using the Beat system, which is an Elastic component, to pull in data and make sure it flows into the system correctly. And then what we've got is our storage, which includes the Elastic stack, holding that data and making it available to our user communities. What we then do is enable data science. So there's a particular plugin, a Python module that Elastic have generated, which allows us to use SageMaker, for example, and query directly into the Elastic engine. Again, Matt mentioned the API keys. So what we can actually do is enable data scientists to use their preferred programming language and actually utilize the power of Elastic, but through a Python SageMaker type interface. In addition to that, we've got the dashboards and the sort of briefing pack side of things. So more the Kibana dashboards, maps, interactive screens, which again, I'll show you in just a moment. So what that's doing is it's allowing us, as was described, to expose that data in a controlled way, but actually enable users and customers to draw value from it. What I'll show you in a moment is driven by an API key or API pull from the internet. So some live data feeds going through that governance cycle, through the schema checking and so on, into Elastic. And then I'll demonstrate some of the dashboards that we've created to illustrate how that kind of data can be brought together in a smart cities sort of environment. So I'll just switch screen. So what we've got here, this is our integration directly into the Microsoft App Store. So this is single sign-on directly through into the Elastic Stack and our sort of complementary services. What we can then do is go straight into our cataloging system. What this means is we can now actually see what data we've got available to us. Clicking through here, all synthetic, certainly the public department data is synthetic, but for instance, what I've got is Transport for London data, and I can now actually see I've got an Elastic index and a JSON file. I've got a Kibana dashboard, so I can now actually start to retrieve that. I've got tags that I can assign to those data sets, and if I were to click through into one of these, I can actually see the different data feeds that I've got, but also the handling instructions of what I'm allowed to do with that, where it's come from, that kind of thing. So we've got a whole governance, so business process driven governance for that. What we've also got is the ability to click straight through into the dashboard. And the other thing that we can demonstrate is the relationship of where the data has been used, or what this data has generated. So the hierarchy of where the data has come from. So, as I say, a quick illustration of that. What I can then do is I can go through into the Kibana dashboard itself. So in this instance, what I've actually got is a map of the UK. The pins, we can browse what these pins are. So we've got various different services around the environment, but the red lines, they're actually key gas pipelines in the UK. We can actually see how these connect from the major ports coming into the UK and how they connect into the infrastructure. I can turn the layers on and off. So for instance, I can turn on the schools in the UK, in London, and it's quite a busy one. There's lots of schools listed in London. So what I can actually do is see those or turn them off to save confusion on the map. Again, all of these different layers can be turned on and off. What we can also do is a live feed. So here what we've got is some Santander bikes. We've got the bike points, the different tube stations, and as the map regenerates, what we'll see is the different types of cycle route that are available in London. If that's going to regenerate, it's being a bit slow. What we can do, I'll flick forward onto the Kibana dashboard. So what we've now got is a very similar screen, but I've now started to put some additional graphing around it. So I can start to interrogate this. And as I drill into the different areas and highlight periods on the map, or change the time period that I'm interested in, the last hour, I can actually get that to redraw and show the different data that's available. What it should also be showing is what we've got here is accidents, so cycle accidents, so we can see what different accidents occurred relative to the cycle sort of cycle stations, the docking points. So essentially what we've done is taken these layers, all these different disparate layers of data, whether it be the gas pipelines, infrastructure like that, or indeed live feed of the cycles. We can filter and show different areas and show what's going on in that sense. So I think if we switch over to any sort of questions, I think we've done 40, sort of 30-ish minutes. Has anyone any questions?
So you can ask questions through the online portal. I've just got it open here. It doesn't look like there's any questions at the moment. What I would ask is if people want more information, they can reach out to either of us directly, and we're happy to help. You can also, from the Elastic side, you can go to elastic.co and either download the software and start running it yourself, which is pretty straightforward to do. There's straight binaries and Docker containers. There's a Kubernetes plugin operator, but you can also run it in Elastic Cloud, which is obviously a SaaS service, so you can sign up for a free trial and start using it that way, which is also an extremely easy way to get up and running, probably the easiest way, obviously. So if people do have use cases where they think that Elastic or Niaxo could come and help them, please do reach out to us. If there's any specific questions we can help with while we're here, then please put it into the platform. So, like Ed, where are the discussions that you're having the most? What are they sort of centered around with the customers you're speaking to in government?
So the challenge that I think people have got is disparate data. We've just come off the back of a shared stand with you guys at DSCI last week, and the repeated problem that people seem to be facing is almost personal data stores, individuals aggregating data, and the wider organization not being able to see what that data is. So having a way of bringing all of that together, and I think using something like Elastic to collate that, to drive that value, is a really powerful thing.
Yeah, I have to explain to large portions of Elastic that have been brought up sort of in the internet age that really the world is run on Excel, and people emailing Excel files around. Obviously, like that works to a certain extent, and Excel is a good tool, but there's a huge information risk if that data is just completely uncontrolled, and either it goes to the wrong place, or people are working off data that's not current, or you just lose important data, or you don't find it, which is pretty much the same thing. So there is a huge risk in working in that model. Like you say, a lot of the benefit is once you have the data centrally, you can guarantee it's up to date. You can guarantee the right people have access, that you've removed access from people that should no longer have it, that you audit who's accessed what, and that you can sort of control that in one single place. So it is really important to have some kind of strategy, but we see it again and again that really business processes are focused around Excel and email, which just it raises huge problems, really.
Yeah, I think I agree with you entirely, and I think one of the other things that is challenging in that space is people not realizing what they've got at their fingertips, or more to the point, isn't at their fingertips. People saying, if only I could do this, if only I could do that. Even some of the sort of simple examples that I shared on the screen a few minutes ago of putting some data on a map, from disparate sources. There is an awful lot of data that's available publicly, but it's about aggregating it and making it intelligible, making it easy for perhaps not a data scientist, but a normal business user to be able to look at it on a map, look at the utilization of something, as in fact demonstrated by the likes of the Uber app that you showed a few minutes ago. Actually, just the customer confidence in knowing that the car is getting closer to them. It's a really really powerful visual demonstration of data.
Yeah, and I guess on the smart cities theme, they range from sort of really complicated scenarios, but like there was somebody the other day complaining that the person that always puts the right bin out was on holiday and no one on their street knew which bin to put out. Like there's really simple services like that can really help just provide the right information to the right people. Trying to find information is generally a nightmare. I mean, you could GPS track the rubbish trucks if you wanted to and have an Uber style application, but I guess it's about like defaulting to information being available and easily available, right? And then the actual ability to sort of build an app which shows you where, like, which bin it is next tomorrow is actually pretty trivial on the UI side. It's always been the integration to the data backend that's been the real problem. So it's like once you put the investment into that data access layer and it's easily accessible by the right people, then you will generate services and user interfaces that you never considered before, because someone else will come and have a good idea and the ability to implement it is now trivial.
Yeah, and in fact, we had an example of that only in the last few weeks, where a customer that we were talking to was saying, well, what we'd like to do is manage our assets more efficiently. What we rely upon is the managers submitting a narrative text report about the status of the sort of corporate equipment that they've got in their possession. And they were asking, how we could use a data science type approach to interrogate that, obviously with the challenges of narrative text. And the assumption, indeed, that those managers are actually stating, I don't know, the front door of the office keeps breaking, or this printer's unreliable. And so we pointed out to them that actually, again, with the accessibility of data, maybe there's a complementary line of inquiry to say, if we could access the data of the utilization of spare parts, so rather than asking the manager to report that there's a systemic problem that they're probably essentially fed up with, that they don't report anymore because it's such a regular occurrence, if we look to the maintenance schedules and bring that data into the picture, we might find that there's an obvious recurrence of a maintenance engineer being called out or a spare part being used repeatedly. And it's that thing of bringing all of that data together and looking at it from a different angle. And those kind of dashboards that Elastic provides are both geo-focused, but also bar graphs, temporal, and being able to click through and highlight different areas and drill into the data. That kind of thing comes to the fore quite quickly.
The other thing that I've seen pretty heavily is around the cybersecurity end. So we're talking about smart cities, like more things being internet enabled, but on the other side you see an increasing amount of like ransomware attacks, right? So we talk about smart street lighting, but you could imagine somebody ransoming your street lights all of a sudden. So I think the ability to build in cybersecurity into that platform from the ground up is obviously also really important. Right?
Yeah, and that's that access control. We mentioned it earlier. The idea of being able to grant, whether it be a dashboard level, granting users privilege to access or indeed be denied access to certain data, but right down into that coding level using the ELAND plugin. For me, that means that we can allow a whole breadth of user experience. So whether you're, let's say, a senior manager who just wants to click on a map in a few minutes between a meeting on a tablet to zoom in on something, or at the other end of the scale, a very comprehensive data science sort of probabilistic interrogation of some data, but at the same time still being sort of directed to the data that you're entitled to see and you're entitled to utilize. For me, that's really powerful. It's that whole stack of what are you allowed to work with and under what sort of authority.
That's great. I don't see any questions in the chat, so I think we should call it a day, unless anybody wants to put any question in pretty quickly. All right, I hope everybody found this session interesting. Obviously, if you do need more information, please reach out to Ed or myself.
Yeah, thanks very much, everyone.